So we have learned the background of ratios and proportions the last 3 days, right? Should be masters by now or close.
Yes.
Biggest thing we need to learn today, this little sign, what does that mean? Guess. What did it mean when we had two little lines? Two little lines was congruent. One line is similar. Okay, what's the difference? What did congruent mean last semester?
Exactly the same.
Exactly the same. What's similar mean then?
Kind of the same.
Kind of the same. What's the difference when they're similar? So it's the same shape, different size. Yep, same shape, different size for similar. So I need to write this over here. Looking at this shape over here, it says PRQ is similar to STU. Remember how we read these? You can look at the diagram or you can look at the statement. Okay? Just by looking at these shapes, would you assume that they're similar to each other?
Yeah.
Why?
Same shape.
Same shape, but
Same numbers.
different size, different numbers, okay? So if I look at the statement, angle P is congruent to what angle? S. Good. What about angle R? T. Angle Q? U. Yep. Or if you look, you can tell by the diagram what is what. The other thing we have to compare is sides. What sides are similar to each other? So if I look at PR, what's PR similar to? ST. Yep. If I look at RQ, RQ is similar to what? TU. And then QR, or QP? US. Yep. Somewhat remember reading those? Yeah? So now it wants us to compare sides. Okay. What did we learn yesterday? What were ratios? How did we write ratios? Fractions. Okay, we're going to make our own fractions. Maybe. So if I start with 10, what side on the other triangle goes with 10? 8, right? We said PR was congruent to ST. So we're going to have 10 on the top and then 8 on the bottom. Can that be reduced?
No. Wait, yeah.
By what?
2.
Divide both of these by 2 to get 5 over 4. Yep. Now, we can't just do one of the sides. We have to do all of them. So if I start with, since I started with 10, I have to keep starting with that shape.
15 over 12.
Yep, so I'm going to pick 15 over, what goes with 15? 12.
You can divide them by 3.
Right.
5 over 4.
Reduce, divide both by 3, we get 5 over 4. You cannot just assume the last one is also 5 over 4. You have to do all of them, just like we did last semester. Okay? So the other one we have to create is what?
20 over 16.
20 over 16. What can I divide both of those by? 4 to get 5 over 4. So what do you notice about all of our answers here? They're the same, so your answer is yes, they are similar to each other. So if you get the ratios and they're all the same, then they are similar. What if just one of them's different? Then they're not similar to each other. Yep, they all have to be the same. Okay? If you did this shape first over this shape, you would still get the same answer. It does not matter which shape you put on the top, which one goes on the bottom. Okay? Yep. Let's look at this one. Just by looking at it, would you say that they're similar to each other?
Yeah.
Why?
No.
Same shape,
Different
different sizes. Okay? What's another way we can prove that they're similar?
The size.
No.
Or the angle.
The angles. Are all the angles marked right? Which angle goes with H?
K.
Okay.
G is M and J is L.
Yep, they all have similar markings, so we're good there. What's the other way we can determine if they're similar? Looking at their sides. So 9,
12.
what does 9 go with?
12.
12. So we have 9 over 12.
3, like it's 1 over 4.
Divide both by 3. We get 3 over 4. Yep. Can we just assume all of them are 3 over 4?
No.
Yes.
You gotta do the math.
Got to do all of them, okay? If I start with 12 now, 12 on the top, what goes with 12? 16.
Divide by 4.
Divide both of these by 4, you get 3 over 4. Can we assume?
No.
Yes.
No. For the last one, what's my last ratio?
15 over 20.
15 over 20. Yep. I heard it. Divide both of those by 5, we get
3 over 4.
3 over 4. So what does that conclude?
They're similar.
They are similar because they have the same ratios. Okay? Biggest thing is if you start with this triangle on the top, you have to keep that triangle on the top the whole time.
Otherwise it won't make sense.
Right.
You can't
Why do you think we can't just stop with these ratios? Why do you think we have to reduce?
I don't know.
Too big.
Too big, okay? Can you look at these and be like, oh yeah, those are the same?
No.
Yeah.
No. You have to reduce to see that they are the same. That's the whole point of the reducing part. Okay? Go ahead and try number 1. Just number 1. Okay, make your 3 ratios and then reduce them, see if they're the same. Only do number 1. Do not do number 2. Okay, we want to determine if A and B are similar to each other. Okay? Just by the sides. So what's one ratio that I can put together?
6 over
6 over 9.
Yep, 6 and 9 go together.
2/3. Divide that by 3, 2/3.
Yep. Now we want to reduce that to its smallest part. So we want to divide both of these by 3 to get 2 over 3. So we did 6 divided by 3 and 9 divided by 3. Okay. Someone raise your hand and give me another ratio we have to try other than Gabe and Chris. Gracie.
Rough.
What? Another ratio that you tried. So we tried 6 and 9. What's another ratio you tried? Alexa. 8 over 12. What do we divide that by? 4 to get 2/3. Are we good so far?
No.
Can we keep going?
12 over 8.
Somebody else give me another one other than the people who've answered already.
8 over 12. Oh, wait, no. 12 over 18.
12 over 18. What can I divide those by?
6.
6 to get
2 over 3.
2 over 3. What do we notice? They are all the same, so our answer is
Yeah, they're similar.
yes. What if one of them was different?
They are
No.
similar then.
Then it would be no. Yep. Look at number 2. What do you notice about number 2? It's a square, rectangle. It's not triangle. Okay. What do we know about rectangles?
Their sides are equal.
Opposite sides, right? We have 2 pairs of opposite sides that are the same. So how many ratios do we have to make?
4.
Do we have to make all 4?
No, you only gotta do 2.
Why?
Because opposite sides are equal.
Right, so you're going to end up having some of them the same. So you only need to make 2 ratios. So what's one ratio I can make?
9 over 6.
Yep. 9 and 6 go together.
Divide that by like 3.
Divide by 3.
That's 3
3 over 2. Good. Doesn't matter that the bigger number's on the top.
No.
No, does not matter. If I started with 9, I have to start with
12.
Over 10.
12 on the other one. So I have 12 over 10. Divide by
2.
2 to get
6 over 5.
6 over 5. What do you conclude about this one?
It's not similar.
They're not similar because
They're not the same.
they're not the same.
That is crazy.
Okay, so for squares and rectangles, you only need to do 2 ratios. Any questions on this concept before we do the last one?
No.
All right, paper over.
Ray.
What do you notice about this diagram here?
There's an X.
There's an X.
Man, that's
Okay. Give me a ratio that includes that X.
X over 9.
Okay.
not
X and 9 go together. So I'm going to make a ratio X over 9. Give me another one.
14
over
and
7.
7.
Okay. 14 and 7.
16
Oh,
8.
fish. What? 14 and 7. 16 and 8. 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 14 and 7.
What do we know about those two ratios if we know the diagram's similar?
Oh, they're
They are supposed to be the same. So what sign needs to go in the middle?
equal.
Equal. We know they're the same, so we know they have to be equal to each other.
Okay.
Now, what does this look like?
It's a little bit of that. Cross
What's it called? We are going to cross multiply. It's a proportion. Okay, we just made our own proportion. Now we have to solve it.
With fish.
Cross multiplying. So we take
With
x
spider.
times 7,
That's 7x.
7x, and then we take 9 times 14,
That is
126.
126.
X equals 18.
Last step, we divide by 7, so we get x equals
rude.
18.
18.
That is number 3, the value of x.
I was gonna solve it
Questions?
so quickly and then you decided
So
to
you
use
still
it.
make your own ratios on this one, just put an equal sign in between.
Is your homework?
Okay?
No, yes.